Okay, fine. Okay, sawa, thank you. So we'll start with today's topic. So we'll have a case study which we'll do on Thursday at 8. So today we are just going to cover an introduction to IoT. So we'll cover two main parts. So what is IoT basically, and what is the impact of IoT to our daily lives. Okay, so this is the first part. So the first part will cover, ignore the first objective, we won't cover that. We look at the meaning of IoT, the definition, then the basic components, then the characteristics, and then the enabling technologies. Okay. Oh, you can see the screen. Okay, so let me try to, I think there is a problem with this Zoom. Okay, sawa. So saying today we'll cover an introduction to IoT. I hope everyone can see good. Yeah. So I'll just repeat. So I hope you're recording. I think I'm also recording. Let me see. Yes, I'm recording. So we'll cover some introduction on IoT. So we'll cover two parts. So the first one is IoT. How do you describe IoT? And then the other one is the impact of IoT society. So those are two topics. So for the first one, which is IoT, to get an understanding of IoT, we'll cover these are the objectives. So the first one we won't cover. So we'll cover the meaning of IoT, the basic components, the characteristics of IoT, and then the enabling technologies for IoT. Then we do the second topic, and then there'll be a case study. So that case study I'll select to present on Thursday. So you'll see it, and then go into your group to discuss, and then on Thursday I'll select a few groups to present what they discussed, and then yeah, and then we things. So this is the first one. So we carry on from the videos, the two videos. The links are here. So once I finish the class, you'll be able to access the videos. So these are the links. I'll just upload these in the e-learning, so you'll be able to see. What is the definition of IoT? So there are so many definitions. I picked this one for Kevin Ashton. So it refers to, Internet of Things refers to uniquely identifiable object virtual representations in an internet-like structure, okay? So here objects can be anything. So buildings, cars, machines, chairs, tables, doors, what you want to communicate to whatever you need to understand. So you have Internet of Things. So one way of looking at it is from that name itself, yeah? Internet of Things. So thing is anything that you want um, to give the ability to communicate. So if you want your door to be able to communicate, for example, let you know when it's open or closed, then it becomes a thing, okay? Then internet, by internet, it doesn't mean that it has to connect to the internet. Internet means it is internet-like. That means it can communicate, okay? So the communication can be through Bluetooth, many networks. It doesn't have to go through the internet for it to be an IoT system. Okay. So this is just the trends, for example. So when did IoT start? Okay, so pre-internet, for people to communicate, they had to be face-to-face, physical, and maybe they will do a phone call and maybe SMS. Okay, and then the email came, so people could send emails. Okay, then the web. So Web 02, it evolved to this, so people could buy things online. Okay. I think currently we are here, or we are exiting this stage, the social media, Skype, Facebook, Twitter. So most people nowadays communicate via these applications and not email and not phone calls. Nowadays people do a lot of social media. Okay. And this is where we are going. So the first four, they deal with people, okay? People communicating with each other. Communicating, but also objects, okay? So we have maybe, let's say, a car trying to communicate with another, not where we are heading, Internet of Things. So this is what it basically means. You have objects communicating with each other. It's only people, okay, to cover for this topic, okay? So this is just an explanation. So when you connect things, you give them the ability to communicate. They can do it over the internet. They can do it not over the internet. So the internet is not a must for you to classify a system as an Internet of Things. Yeah, we'll look at the characteristics later, and then you'll be able to see what are the characteristics of an Internet of Things system. Okay, so machine-to-machine communication is key. Here you have an object trying to communicate with another object. So maybe your door trying to communicate maybe with the lights. Okay, so when the door is open, the logic is that maybe someone is coming in, so the lights go on. So instead of you having to turn on the switch, this happens automatically. So it's sort of like the door sends the to the light bulb and then it comes on. Then when the door closes, maybe it assumes there's no one in the room, so it goes off. Machine-to-machine communication. Okay. So these are other definitions of Internet of Things. So to some people, IoT means smart, okay? So smart environments, Internet of smart farming, Internet of smart transport. Some people consider that as still IoT, okay? And we look at the characteristics, and then you'll be able to decide for yourself, is it an IoT system or is it not an IoT system, okay? So basically, when you have an IoT, so by now I think you're familiar with the sensing and actuating sensors. You need a sensor, you need an actuator, but mostly there'll be the sensor part. So you have to sense something. You're trying to get, so you have an object, it tries to maybe upload it or you send it somewhere else for some decision to be made or something else. Yeah? So IoT also comes with and then you will make the smartness. It can be called ubiquitous sensing. So these are things that people use try to explain what an IoT system is. Okay. So if I was to have an equation for an IoT, what are the things that need to be there for me to maybe classify something as an Internet of Things? I'll need a physical object. So here, it can be anything, a door, a chair, a car. So that's the physical object. Then I attach maybe a controller or a processor, maybe sensors and actuators so that it can sense something. It can use the actuators to do something, okay? Then on top of this, I enable this here to communicate. So it can be through the internet, it can be through Bluetooth, it could be through RF radio frequency, whatever it is, yeah? Once I give it the ability to communicate, then it becomes an Internet of Things, okay? So what are the components of an Internet of Things? So there's the hardware, you have your sensors, actuators, microcontrollers, okay? Then you'll need to store. If it's going to communicate, it means it's going to send data somewhere. You need to store that data, okay? So that for storage, and then after you need to analyze it. For example, you want to make, so here analysis can be, yeah, you want to make a decision. So you get data, but you want to make a decision based on that data. So there is some analytics involved, okay? So all the storage and analytics will be in there in the middleware, okay? Then there's a presentation. This is optional, but in some places, in some maybe applications, the user wants to see what is the trend of the data. Or for example, I want to monitor the temperature. What is the trend? So I don't want to see the data maybe in form of maybe numbers. I want to see a graph, okay? So it has to be visualized, okay? So these are the three main components. Okay, okay. You need this hardware to communicate. So there has to be a network. So your network can be IP based, it can be data based, okay? So whatever it is. So in the middleware, you'll have all this. Enables this hardware to store, communicate, and everything. Then you have the presentation, okay? So what are the characteristics of an IoT? So we have 5 characteristics. So for example, how do you classify X as an Internet of Things, okay? So it involves some smartness, okay? It doesn't have to be artificial intelligence, but there is some smart in the way it operates, okay? So for example, if your fridge can detect when your milk is running low and then give you an alert, okay? So that there's some smartness in that. You might implement that without using artificial intelligence, but there's some smartness, okay? If, for example, I walk in the room and then the lights go on without me doing anything, there's that smartness that is there, that light. So that light can be considered an Internet of Things because it's able to sort of do something automatically without me maybe requesting or maybe pushing a button, okay? Then there's connectivity, okay? So it has to sort of communicate, okay? So maybe your fridge detects the milk is low, then maybe sends a message to you. There's some aspect of connectivity, networking, okay? Then sensors. So this is obvious. So if you want maybe your door to detect when a person is coming in, you have to use a sensor milk, okay? So here under sensors, you can have sensors and actuators, though actuators may not be very, that they only need a sensor, but also actuators will fall under this number 3, okay? Then active user. Okay, so this one, for example, it will require you to maybe, it will sort of require interaction from you, okay? For example, I walk in the room, my presence is the interaction, the engagement, that is what causes the light to maybe go on or go off, okay? Maybe the fridge, how will it interact with me? Maybe when I maybe touch the door handle, okay? So there's that interaction between the user and the system. Although it's automated, there's something that it sort of monitors from the user before it does something. Okay, so it just doesn't work. For example, the light just doesn't go on without the user being there. So there's some sort of interaction between the system and the user. Okay. Then small devices. Okay, so the smaller the better. So IoT are built on very, very small devices. The reason for this is so that it can use less power, it can use less data to communicate, okay? So it's cheaper in the long run to have it, okay? So it's implemented more of two of these or three of these or all of these, okay, it depends, yeah? But these are the characteristics you look at when you're trying to decide if a system is an Internet of Things or not, okay? So what are the application models? So we have device to device. For example, if I have my door being able to communicate with the lights, that's device to device, okay? So, the door opens, the light go on, device to device, okay? There's device to cloud. So my fridge detects that the milk is low, it sends that so you have maybe it sends a tweet to me or something like that. Okay, so you have device to cloud can communicate over the internet without any intermediary between. So the device can directly just send data over the internet. So that is what I mean by device to cloud. Then you have device to gateway. So in this one, you have, for example, you have your device, but for example, let's say it wants to connect to the internet, it has to go through maybe a modem. Okay, so the modem is a gateway. Okay, so from the device to the gateway, and then the gateway now decides what is the destination. Okay, is it a server or is it an application to a server, maybe a database or maybe an application? Okay, so you have device to gateway. Okay. So far, any question? So take note of these questions here before we move on to the next thing. So take note of the question. So is there any difference between ubiquitous computing and IoT? Then give real life examples of device to device communication, device to cloud communication, device to gateway communication. Okay. Think about those. So what are the enabling technologies for the implementation of IoT? So we are looking. So here we are going to look at the technologies that make it easy for us to implement IoT solutions. Okay. So we'll look at 5. So RFID, so we call this RFID technology because this is how IoT started. It started by an RFID project, but in reality, it's meant to it's stand for sensors and actuators. Okay, so when you're explaining it, sensors and actuators. Okay, so you technology. So you have new sensors that are becoming even smaller and they have maybe bigger capabilities. So RFID is the sensors that sort of initiated the idea of the Internet of Things. Okay, so that RFID technology. So it was able to be fitted in a small device, a sensor, and then the sensor could be able to identify maybe a car, okay, and such things, okay. I hope it's making sense. Yeah, so we have it as RFID, but in reality, since now we've progressed from there, we have so many sensors. Think of it as the way sensor technology has advanced Internet of Things. Okay, so now we have as we go on with life, we have more sensors that are smaller, that are even more capable than maybe 10 years ago, and something like that. Yeah. Then we have wireless sensor networks. So these are networks that allow you to connect sensors to each other. Okay, they use protocols that are efficient in terms of power, in terms of memory. Okay, so wireless sensor networks. So this is, if we were to go deeper into this is like a whole unit, wireless sensor networks. It's so deep, it has a lot of literature. But for this course, we'll just mention it as an enabler for IoT, okay? But if you really dig deeper, you'll realize that it's very deep. It has a lot of content, okay? So, and this is different from IoT. So you might get confused. Maybe you see sensors connected and you try to maybe classify that as IoT. It's different, okay? So this is wireless sensor networks. It's a technology, okay? I think it will become clearer when we start looking at the protocols for communications. You'll understand how wireless sensor networks has enabled IoT, okay? So this is just the ability to have wireless networks that can run on low power, low memory, low cost, okay? So it enables us to connect sensors, not through the normal IP addressing that we know, or maybe not through the normal Bluetooth that you use on your phone, but the other Bluetooth technologies that are clearer as we go on, okay? So these are just more explanation. So I'll upload these, yeah? Then I addressing. So here the main enabler is the IPv6, okay? So IPv6 can support so many addresses. So that means you can identify anything uniquely over the internet, okay? IPv4, it means you have to use proxies, and then if you use proxies, it means you can't really identify which device sent a message. But with IPv6, you can identify exactly which device sent a message using the MAC address, okay? Or the physical address of that device. Okay, so IPv6 is another enabler of IoT. So in terms of allowing devices to sort of identify each other correctly. Then there's data analytics. So this is the area that is, I think currently a lot of research is being done around here, data analytics, trying to predict, you're trying to analyze, all those fall here. So you realize that AI is advancing and now it's able to do much more. It's much more things with less computing power and with less time, okay? So go on, that intelligence, it allows us to connect apart so each other on a level that they couldn't do maybe 10 years ago, okay? So data analytics. Then, yeah, so artificial intelligence. So yeah. Then also cloud storage. So how does cloud storage fall under this? Because cloud allows us to have, for example, you can rent bigger storages at lesser prices than maybe 10 years ago, okay? So that technology, you have a very small maybe device, but it's capable of storing so much. So you're able to collect, you can install your IoT and then it can able to run for 10 years with it sending data to your cloud without it getting full, okay? And if you have 10 years of data, there's a lot you can do. There's a lot of analytics you can do from that data, okay? You can learn so many patterns, you can learn so many things, you can have so many artificial machine learning, and you can use it to predict a lot of things. So there's visualization. So this is just trying to convert raw data into a form that a human can easily understand for decision making. So this one deals with the graphs and pie charts and just having to represent that data I think for the last 2 or 3 years. So it allows you to have data from different sources, and you can actually just bring them together, and you can draw so many graphs from there. You can actually correlate a lot of data from different sources, different formats. They don't have to be the same format: CSV, JSON, Excel. You just throw them into the Power BI, and then you can able to draw graphs and do so many things, okay? And of late, I've realized that that's where employment is going, because now, back in the days, people would be employed maybe for just managing, maybe you just take care of a server. So maybe a company has a data center and your job is just to monitor the server. If it crashes, you go there, uh, look at the problem, fix maybe the mouse, fix the RAM, and then you turn it back on. But nowadays, the kind of jobs that are being advertised are these ones to do with analytics. So you have a company just employing someone to do Power BI, to analyze their data, their customer data. So what he does is just gets data from about their customer, throws it into the Power BI, and try to come up with different analytics about customer behavior or how to boost their sales and everything, okay? So take note of these questions before we move on to the next thing. So what is the difference between a wireless sensor network and an IoT? So this one will require you to do some research, a little bit of research. So you'll be, for now, I think you can tell what is an IoT, but for wireless sensor network, you need to do a bit of research to really understand what it is. Then the difference between cloud computing and normal computing, okay? So by now, I think in fourth year, you should be able to differentiate these two. Cloud, okay? So for example, if you have your laptop, or maybe you host maybe a website, which, so if, for example, you're hosting a website, which platform are you using? Are you using the normal shared hosting, or are you using cloud computing? So what is the difference, basically, okay? So we move on to the next thing, the next topic, the impact of IoT. So here we want to look at how IoT has impacted our lives, okay? Then after this, we'll have the case study. So I'll have you guys look at the case study, I'll upload the notes, you look at it, discuss it, and then on Thursday, we'll select a few groups to discuss the case study. So these are the objectives. So these are the things you're going to look at in this topic. So what is the impact of IoT to our society? What are the issues that come with IoT? Okay. The pros and cons, the merits and demerits. Okay. This one, the pros and cons, I won't cover it, but I'll have it as a question. Why? Because once we cover the issues and the impact, you can be able to derive the pros and cons, the advantages and disadvantages of IoT penetration. There is no need for me to repeat them. You can just derive them. So if you sit down and think about the issues and the impact, you can be able to derive a few advantages and a few disadvantages of IoT. Okay. Then lastly, we look at the application areas of IoT. So I'll just look at a few application areas and I'll just mention, I won't go into details because quite many and they are quite sophisticated. Okay. So I won't play the video, but I'll upload this. You'll be able to see. So this is a quote from Kevin Juston. So just read it, and then we move in. So this is a quote from Kevin Ashton. So to read it, you realize that there is a lot of issues that will come with if we fully adopt IoT. Okay, so we'll try to look at a few of these issues. There are many, but we'll look at the main ones that concern us as computer scientists. Okay, so depending on your background, you can have so many issues, but for us, we're interested in the ones that concern us as computer scientists. Okay, so we start with the positive impacts. So we look at the individual, company. Okay, so individual, we can have safer systems. Okay, so we can have safer, and have activity detection. Okay. So for example, if you have old people fall a lot. So if we can have a sensor that can detect when an old person has fallen, then it will help us to actually help them, because when they fall, sometimes they need help. And if they don't get that help, they can get very bad injuries. Okay. Comfort and convenience. Okay. So for example, there's a lot of research going into trying to help blind people to see using artificial intelligence and IoT. Okay, there's a lot of research going into trying to help people who are maybe physically challenged to have a normal life, experience a normal life. Okay, then improving lifestyle. So nowadays, the smart watches, you can measure from your heartbeat, you can measure your blood pressure without even having to see a doctor. Okay, so you know so many things just by just having a reduced cost of living. So in the video you saw what Barcelona has done in terms of smart parking, in terms of then smart gardening. So if you automate these things, for example, if you have the lights on the roads turning off when there's no one on the road and only coming on when there's maybe a car approaching, then it will save a lot of energy and cost to the society. So these are just, I'm just mentioning, so there can be so many. So I'm just trying to mention so that at least you get a line of thought. So if you're thinking about how IoT has positively impacted an individual, you have at least a line of thought so you can add more of your ideas to these. Okay. So to the society, there's public safety. Okay. So for example, terror. So a lot of intelligence goes into trying to detect if this is a bomb or not a bomb. Okay. Trying to analyze the behavior of terror organizations. Okay. To make, even if they are gunned down, but the data has reached this other side. And we can use that data to save lives, okay? Protect the environment, okay? So cars nowadays, they have a lot of sensors, the engines, that's just one example. There's a lot of sensors. There's the oxygen sensor, which produce so much carbon emission, okay? So a lot of automation goes into the car so that the amount of carbon they emit to the environment. So that's just one area. To farms, okay, increase in productivity, there's marketing, cost in reduction. So in cost in reduction, you can look at maybe manufacturing industries. So instead of having maybe people trying to maybe design or maybe come up with a part, you can have a machine that is more accurate, maybe a particular design in seconds, than have employ a person that will do the same design maybe 1 hour, take 1 hour to do the same design, and maybe it will have of the human nature, because of our human nature, okay? So I haven't talked of the negative impacts because I want you guys to with those, okay? Then the merits and demerits and disadvantages that come with IoT. Now, these merits and demerits, before you actually try it, I'd like to cover the issues that come with IoT, because this one, the merits and demerits, you easily get them from the issues, okay? The ones that we are going to cover next, okay? So what are the issues that come with IoT? 5 main, okay? Security challenges, privacy concerns, interoperability, then legal, and then economic and development issues, okay? So security issues, so how? Now, if we have everything being able to connect, so that means you have a network. A network, it means every node in that network is a potential a point for an intruder to get into that network and maybe get into your home or maybe get into your computer or whatever it is, yeah? So IoT, of IoT, you have to talk of a network. And once you introduce the aspect of a network, it means every node can be, so every node can be attacked and someone can get into your system, okay? So you have to secure everything that, so every object that you attach a sensor and ability to communicate, you have to make sure that you sort of secure it. So there are many ways of overcoming this, but I won't discuss it. I want you guys to think about it. So this is an issue that comes with IoT, but that doesn't mean that we have to stop advancing IoT. We just have to look at solutions that will solve these security. Okay, so if the problem is having so many nodes, then maybe you reduce the number of nodes. If the problem is how the communication is done, then maybe you can introduce authentication and so forth. Okay, so these are things that you need to think about. Okay, so these are just trying to bring out the points more clearly. So IoT, so it provides malicious people with so many entry points into your network. Then secondly, IoT devices have long lives, small, and then they require little power. And then the way they're designed, for example, if you have if you're designing a system for, let's say you have your car and maybe it has a sensor that allows it to maybe measure the amount of fuel, and then sends it to your phone. Or for example, it can measure the load of your car and then send it to your phone. Okay. That device can maybe last for 20 years. Okay. And as we go on, people are getting smarter and they can hack it, because maybe it will outlive the company that manufactured it. Means you won't have updates on how to maybe improve on its security, maybe take care of vulnerabilities that come up as we advance the technology of maybe networking. Okay. Then static firmware. Some devices are such that you cannot upgrade. So it means if that device has a loophole, then that loophole cannot be taken care of. Okay, so especially these devices that come with a read-only memory, that you cannot even upgrade. So if it has a loophole, then really nothing you can do about it. And then there's abstracted operation. So most IoT systems don't allow the user to set maybe maybe set the preferences. So for example, if you have maybe a security camera, uh, most of them don't allow the user to maybe sort of for example, just the camera without having the system. So if the user cannot sort of want this data to be collected, maybe I don't want this node attached to maybe send information to the internet. If those are preferences, then it means maybe I don't want to. So so that is for security. The other one is privacy. So privacy and security are two different things. Okay. So privacy here is where the IoT system maybe collects data that the user does not want the device to collect, okay? Or maybe sends information that you don't want public over the internet, okay? So for example, if you have your camera and then maybe the camera is connected to the cloud and it's on 24/7 and it's in your house, so it means it will always be recording whatever you're doing in the house. So whether you want it or not, okay? So that is a privacy. So it doesn't mean that it has been attacked, but it means sometimes it doesn't know when to stop. For example, when you want to have your private time, it doesn't know how to stop so that you can enjoy your private time. So that is just one example, okay? So privacy preferences. So for example, most IoT devices, they don't allow you to preferences. And you'll see when you'll be designing your system, you realize that they are single functioned, as we mentioned in the first classes. IoT systems are also single function. They are just meant to perform a particular task. So if it's supposed maybe to just maybe record videos, you don't give the user much freedom. So what you want the system to do code, so the user will either have it on or off. That's maybe the only thing the user can do, but maybe it won't allow the user to maybe add more preferences, okay? Then if we assume that, for example, some rooms in your house, it means setting the privacy for each camera. It's a little bit tiresome, yeah? Or for example, if you set privacy on those devices will be very difficult, okay? Then social norms, these are machines, of course. They don't have that knowledge of knowing. Maybe the user needs some alone time or something like that. But maybe we'll get there with artificial intelligence. We never know, okay? Then the other one is proximity. So here, for example, if you have a public camera, let's say you're just trying to monitor, for example, let's say in Strathmore, they have a camera, they put a camera on the front gate just to monitor the people that are coming in. So it means even those people that are not coming into Strathmore will be recorded by that camera. So that is what is meant by proximity. So uh, they are not coming into Strathmore, they have no involvement with Strathmore, and they don't need their photo taken by the Strathmore camera because they have no business with Strathmore. Okay, so that is privacy. Then you have interoperability. So this one you'll notice this is actually a major problem, but nowadays things are become a little bit. But you'll notice that Arduino does not work with Raspberry Pi, for example. You want Arduino to work with Raspberry Pi, it's just a big challenge. And you realize that there are other sensors that only work with Arduino. So this is interoperability. So mostly companies do purpose, okay? So for example, Arduino wants you Arduino sensors. So they make sure that Arduino sensors provide more certain, okay? So it's difficult for maybe a vendor's device to communicate with another device that is from a different vendor, okay? So these are the reasons. So consumer lock-in, manufacturers just want you to use their devices. Then there's the technical and the cost constraints. So for example, you can have, let's say Zigbee, it's supposed maybe to perform a task, and then it's running on Bluetooth 2.0. Then you have another device, you want it to communicate Zigbee, but maybe it's running on Bluetooth 1.5. So that is a technical issue. So these two devices are both on Bluetooth, but they are on different standards, so they can't communicate, okay? So that is another thing, okay? So absence of international standards also. So for example, as you go on, you realize that uh, some devices come with the new technologies, okay? So for example, Zigbee will launch a standard that can only be used in Zigbee. It's new, okay? Can I think of an example? Let me just use the one for Bluetooth again. Let's say Zigbee maybe come up with a new Bluetooth technology. So that means any system that does not use that technology cannot communicate. So, and before that standard becomes international, it will take time. Okay. Then there's, yeah, so this one is still standards, the same point. Yeah, still standards, okay. Then there's the legal issues. So for example, if a smart car knocks down someone, who is going to be arrested? There's no driver. Arrest the developer? Do you arrest the owner? So these are legal issues that come with IoT that maybe the law has to now go back to try to see in such a scenario what happens. So who is liable? Okay. So when you're designing an IoT system, you need to test all use cases because sometimes you don't know how your user is going to use your system. For a security purpose, then someone uses it to spy on someone. So how do you sort of your system from being used to spy on people and instead be used for its intended purpose? Okay. Is that one. So unforeseen ways. Okay. So testing all use cases is hard. Then some people use it for the wrong intention, and you have no way of just trying to prevent that. Then the long life of IoT devices. Okay. So your company might actually your device might outlive your company, and then in that case now you can no longer even update your device. Okay. So the fourth one is almost the same as the first point. So testing all the use cases. So for example, we're driving a driverless car. It's difficult to test because the road has so many scenarios. So testing all those it's very difficult, but we are getting the AI. So I hope some of these issues will go away. Okay. We have economic issues. So by now, it's obvious that if you need to design, if you then you need to have networks that can support not only people but devices. So it means our internet, we need to expand our example. So for example, if we have 2 billion people communicating over social media, add now devices. For example, cars now want to send data over the internet. You have maybe 5 billion things that also want to use that same internet. 5 infrastructure that can accommodate all that communication. Okay. So that is developed world, but in countries that are underdeveloped, where they are using to deploy some of these IoT solutions. So that's why you realize that sometimes Safaricom tries to maybe deploy some system, maybe the voting system, but in some areas they can't that system because of the infrastructure. So they have to go back to the manual because they can't even do maybe a 2G connection in that area. So they have to go back to the manual system. Okay. So any questions so far? Now I've talked about the issues. Now you have 2 things that you need to think about. From these issues, try to come up with the merits and the demerits of embracing IoT. Then the second one is, how do you sort these issues? These issues are real, but it doesn't mean that we stop doing IoT because it's difficult. We need to come up with solutions that we can use to sort of solve these issues. Okay. Some are straightforward, some are not straightforward, some need more time, some need more technological advancement, but it's up to you to discuss and see what strategies can you use to address these issues. Okay, so that is the exercise that you need to take note of. Okay, so what are the application areas? So there are so many. So I just said I'll just mention Internet of Smart Living, Internet of Smart Cities, Internet of Smart Environment, Internet of Smart Industry, Internet of Smart Health, Internet of Smart Agriculture. There are so many, okay? And as you can tell, The name just tells you where you can apply it, okay? Of smart living. These are just IoT systems under this application area. So remote control appliances, they can turn on and off. At work, you forgot to turn off your maybe TV, you just turn it off without having to go back home, okay? Refrigerators, you are, okay? They can now communicate with your smartphone, okay? And the milk is there detection systems. When the door is opening, you can tell if someone is becoming smart. You have to efficiently use water. How do you efficiently use energy? Okay. So we have this structural health, lightning, safety, transportation, smart parking. So these are just applications where you can apply IoT. Smart environment, air pollution, forest fire detection, weather monitoring, okay, water quality, smart industry, explosive and hazardous gases, maintenance and repair. So you have sensors that tell you when you need to repair a particular equipment and so forth, okay. Smart health, medical fridges, smart what, okay. So these are things you just need to think about. So the meaning of smart in the computer field, and then in education and research, is there anything like Internet of Smart Learning and Research? Food for thought. So this is the case study. So if there are no questions, this is the case study. Okay. Select a few groups to present, and then I'll see if I'll give you some more exercises, and then we can call it a week. Okay, so I'll upload these notes in the e-learning, you can have them. So if there's no question, I think we can stop there for today. You have a nice day. Enjoy the rest of your day. We meet on Thursday, and stay safe. Okay.